Okay, chapter 5. We're covering 5.1, which covers the mid-segment theorem. Just so you know, chapter 4 was about comparing two triangles. Chapter 5 is about relationships within one individual triangle. So understand the difference. The biggest thing for 5.1 is understanding what a mid-segment is and how it functions. So a definition of a mid-segment of a triangle, it's this segment that joins the midpoints of two sides of a triangle. So if you look at the picture here, triangle ABC, I can look at it and know that DE is called a mid-segment because I can see that D is a midpoint by the markings here. I can see AD and DB are the same, so I can call D a midpoint. I can call E a midpoint for the same reason. I can see BE and EC have the same length. So I can call this a mid-segment. So be able to identify what a mid-segment is. The other thing is the mid-segment theorem. This is how it functions and what it does to help us. So there's two things that you need to know. First of all, be able to identify that this is a mid-segment by looking at it. And it has two things that are important about it. So it's parallel to the third side. So DE connects AB and BC, but DE is parallel to AC. That's going to be important because we'll be able to apply a lot of the ideas from chapter 3 that we learned about parallel lines and certain angles. So it's parallel to the third side, and it's half the length of the third side. So looking back at my picture, DE is half the length of AC. But just like any formula, we know DE is half of AC, but if you move that to the other side, 2 DEs equals an AC. So if you stop and think about what that means, 2 of these gives you 1 of these, or half of this gives you 1 of these. That should make sense to you. Let's look at a couple of examples. So in the directions, it tells us that DE is a mid-segment. As soon as they tell us that, I know that D is a midpoint, I know E is a midpoint. And it just so happens we're using the same letters, don't get caught up on that. So the first example, because I know this is a midpoint and this is a midpoint, the idea that we need to remember is that DE is half of X, or 2 X's give me a 7, or give me the DE. So the way I set this up is half of this length equals this length. And when I solve this simple equation, I found that X is 14, which should make sense, because if this is 7, this has to be 14. Example 2, remember all the triangles aren't going to look the same, it's just going to be a triangle. So again, we know that DE is a mid-segment, so I know this is a midpoint, I know this is a midpoint. By knowing that this is a mid-segment, that tells me this is a midpoint, which means DC and AD are going to have the same length. So if DC is 8, AD is also going to be 8. That's important. Going in the opposite direction. Again, the directions told us that DE is a mid-segment. So 2 of these gives me 1 of these, or half of this gives me this. The way I set mine up is I took AC and multiplied by a half, or divide by 2, and that would give me my DE length. So half of 34 gives me 17. These are the basic ideas that I need you to be able to understand. This takes it a step further, of course, integrating some algebra into the examples. So in triangle GHJ, D, E, and F are midpoints. So that tells me a lot. If I know D is a midpoint, I know that these two segments are the same. E is a midpoint, these two segments are the same. F is a midpoint, those two segments are the same. But that also tells me a little bit more. Because this is a midpoint and this is a midpoint, I know I can call DE a mid-segment. Because F is a midpoint and D is a midpoint, I can say that FD is a mid-segment. Now there's a lot going on in this triangle. Before I even look at my example, I know that FD is a mid-segment, which is going to be half the length of HJ. I know FE is a mid-segment because it's connecting two midpoints, and FE is half of GH. So see everything that's going on in that picture that's important. This is the information that's given to us. So we're given that EF is 2x plus 7, and GH is 5x minus 1. So very similar to what we did with the simpler examples. I know 2 of these gives me 1 of these, or half of this gives me this. So you can set it up either way. I like to use the whole number when possible because we know we don't like to use fractions. So what I did was I said GH equals half of FE. And all I did was plug those in. So GH is 5 plus 1, FE is 2x plus 7. And then of course, simple equation solving, I get x is 15. Be careful as always, make sure that you answer the question. Or ask what EF is. We don't really, well, we need to know what x is, but we have to keep going. So once I know what x is, I have to answer the question what EF is. And EF is defined up here as 2x plus 7. So I'm going to plug in 2 times 15 plus 7, which means EF is 37. I can go through a lot of examples in this picture, but understand where the mid-segments are, the relationship between the mid-segment and the third side, and also the idea that what these midpoints mean for those all three sides. As always, I'll answer questions before you take a quiz on this next block, and here is your homework. My answer keys, as always, will be posted online.